make sure it's useful. Menu 1.5. Clear the screen. This should work. Okay. Applying trigonometric ratios. In this activity, you will use your knowledge of trigonometric ratios to solve problems. The good stuff. At an altitude of 1,000 feet, so there's our 1,000, the angle of depression from the balloon to the landing zone, remember, angle of depression is downward feeling, okay? So then the measure of that angle is 15 degrees. How far is the balloon from the landing zone? This line, which is green because it's the hypotenuse, is our unknown, h. From 15 degrees, remember, it goes theta, then h, o, a. We have 1,000 feet is the opposite side. And so therefore, what we are able to do is write a trigonometric ratio that will help us find the value of the unknown side, h. Opposite and hypotenuse is a sine ratio. Opposite over hypotenuse is a sine ratio. I'm in radians. I got to change this over to degrees. So I'm going to go up here to the gear. I'm going to click document settings. I'm going to go down to radian, change that to degree, lock it in. Now we're in degree mode. So from this structure, I'm going to write 1,000 where the opposite side is. 1,000. I'm going to continue using h. Don't know what that is, but it's going to equal the sine of 15 degrees. Now to solve for h, cross multiply happens, and then we're going to divide. And when we're done, this is h equals 1,000 over sine 15. You need to go confirm that for yourself. However, I can tell you, with the process of cross multiplication, we wind up with 1,000 over sine of 15. This is an exact answer, but we should go to the calculator just to get some support. So 1,000 divided by sine of 15 degrees. 3,863.70 feet. H is approximately equal to 3,863.70 feet. I'm going to continue answering these questions. At any point along the way, you should pause, skip forward, and before you skip forward, work the question out yourself. Maybe write in pen or pencil. Don't erase anything. Just draw like a line through your work, because what you'll come to realize is that mistake that you made that you wanted to erase to be perfect actually might inform you about future mistakes and confusion that you can avoid if you're aware of it. Question 2, at this point you should pause and you should work question 2 out yourself and then see if we have the same answer. If you don't want to do that, I'm going to keep talking, but that's the plan moving forward. I'll give you a chance to pause and keep going. An aircraft uses radar to spot another aircraft 8,000 feet away at a 12-degree angle of depression. So I believe this is the 8,000. And I am right. Determine the vertical and horizontal, so in this case, vertical and horizontal separation between the two aircraft. Let's use a Y for vertical. Let's use an X for horizontal. So therefore, the opposite over hypotenuse is going to be the sine of 12 degrees. Y is going to be equal to 8,000 sine of 12 degrees. Y is approximately equal to 8,000 times sine of 12. 1,663.29 feet. Okay, so then X over 8,000, because it's adjacent over hypotenuse, is equal to the cosine of 12 degrees, which means X is exactly equal to 8,000 cosine 12, or X is approximately equal to 8,000 cosine of 12. 7,825.18. 7,825.18 feet. Calculator work. Glare. There's my calculator screen. Question 3. To measure the Grand Canyon's width, a surveyor stands at a point on the north rim of the canyon, I've been there, and measures the angle of depression to a point directly across to the south rim of the canyon. I haven't been there. Determine the width of the Grand Canyon at the surveyor's position. So we have X, we have 1,097 feet. Determine the width of the Grand Canyon at the surveyor's position. Honestly, what we have is the request for X, and we have this vertical height. I don't need any of the other numbers, although that is how intense of a drop it is. Over a mile, it falls on one side, and over like a mile and a half, it falls on the other side. If you haven't been there, go. It is truly a Grand Canyon. Okay, so tangent of 19, because it's opposite and adjacent. The 19-degree angle of depression, looking downward. So therefore, it's going to be opposite over adjacent, 1,097 feet to X. And honestly, when you're there, you don't notice that it's 1,000 feet higher on the far side because it's so expansive that it just looks flat as you look across and then look down into the canyon itself. Okay, cross multiplying. So multiply both sides by X, divide both sides by tangent 19 degrees. We wind up with 1,097 divided by tangent of 19 degrees. Now, I could use another one like cotangent and maybe design this a little bit better, or I could use the complement to angle 19, but I'm trying to avoid that. I'm just trying to use what we have in the picture exactly as it is and just deal. Okay, 1,097 divided by tangent 19. So 1,097 divided by the tangent of 19, 3,185.92 feet. 3,185.92 feet. Yeah, that would work. By the way, if you're not sure that I know what I'm talking about, it'd be 1,097 times cotangent of 19. Or it'd be 1,097 times tangent of, let's see, the complement to 19 is 81? No, 71. All the same. All the same. Okay, question 4. Darius is camping in the woods. He walks towards the ranger station before stopping to climb to the top of a tree to locate the station. Determine the angle of depression formed by Darius's sight line to the ranger station. So it's this part right here that's the unknown. And when you don't know the angle, you use inverse. We do know he climbed the tree. He's got 18 feet from where he is to the tree. So then the rest of this would be this distance here, yeah, would be 32, because 50 take away 18 is 32. Okay. That bell is not for you, and the bells are wrong. Don't pay attention to that one. Okay, sorry. Determine the angle of depression formed by Darius's sight line to the ranger station. So we have a height of the tree. We have to... we could do that. We could. Something's missing here. He's walking towards the ranger station. Determine the angle of depression formed by Darius' sight line to the ranger station. We need to know the height of the tree. You know, the answer key tells us. Why is that there? 18 and then 32. Oh, gosh. Okay, I didn't even catch it right there. That's a 90-degree angle, and because it's a 90-degree angle, we have to use geometric mean. Oh, they're so tricky. Okay, so then this geometric mean is the top and the bottom of two separate proportions. where 32 is one of them and 18 is the other. So then y squared equals 18 times 32. And then, hey Siri, what's 18 times 32?
18 times 32 is 576.
Which the square root of 576 is 24. So then y equals 24. Oh, that's... Hey, you... Okay, pay attention to how there's a right angle and then this tree forms a right angle to the ground. So that's how we know, how I know that I'm having to use geometric mean. There's right angles all over the place. And therefore, we got to set up geometric mean like this and the other two sides like that. Now that we know the height of the tree and the distance the tree is to the ranger station, this becomes an opposite and hypotenuse. No, adjacent. Opposite and adjacent. So theta HOA. And we know the opposite and adjacent numbers, so that means that x degrees is going to be the tangent inverse of the opposite to the adjacent. That one, tricky, tricky, tricky. Okay, so tangent inverse of 24 divided by 32. 36.87 degrees. Approximately 36.87 degrees. Thank you for watching, commenting, liking, and subscribing. I'll see you in the next episode.